are going to discuss differential equations of first order and first degree. So basically, before starting the unit, let us all have an idea of what is a differential equation. If you have remembered going a resort or going on a trip, you have seen many trees, right? So when you see a tree, apart from a tree, leaf, flower, barks, etc., can you see any kind of pattern in the nature or any kind of formations? Example, this is a childish trick we would most probably try it. If you are trying to throw a water, sorry, I'm very sorry. If you are trying to throw a stone in a water, what will happen? You see that there are many ripples forming in the water. This was a childish game. We started from our childhood memories, right? So why do you think those ripples are forming? Is there any kind of formation or any pattern in that? These all are same circles, or indirectly I can say that they are having same radius or same center. Any idea about that? No, it is having same center but they are not of same radius. That is, every circle is having same center but it is not having same radius. So such circles are called concentric circles, which we have learned from our lower mathematics. So that is the edifice for learning differential equations. Not only water ripples, you can see many other formations. If you have remembered, while listening to songs in olden days, the technology was like you can hear the rhythm of the music, that is the waves. In terms of waves, you can see whether the oscillation of the wave is increasing or decreasing. When a song is placed at the peak of the song, that is, if it is a beat music, you can see that the curves are going up and down, and if it is rhythmic music, the curves will be so uniform that there is a continuous pattern between them. So these all patterns are basically formed on the basis of differential equations. So what do you learn in differential equations? So to remember, we are having two differential equations. One is ordinary and another one is partial. But here I have only displaced ordinary because now we don't have any requirement with partial differential equation. But in further futuristic studies, we will definitely even see what is a partial derivative as well, right? So starting with the definition of ordinary differential equation, a differential equation is said to be ordinary if it is having ordinary derivatives. Now what do you mean by ordinary? It isn't an ordinary terminology. Here ordinary in sense we are saying that there is only one independent variable in the differential equation. Now you can say, ma'am, you didn't define differential equation. So it is very easy. When there are derivatives in the equation, you can say it is a differential equation. Assume here I am having the equation dy by dx whole cube, yeah, equal to 0. It can also be a differential equation, right? So if you are having derivatives in the equation, it is a differential equation. And if that differential equation is consisting of only one independent variable, then it is called a ordinary differential equation. Now you can see in the example there are dy by dx, y. Only one variable is there. Why one variable? No, there are two variables, that is y and x. So here y is what? Dependent or independent, or x is dependent or independent. Do you have knowledge of dependent and independent variable? So here y is the dependent. No. Is it independent? Okay, let's keep trial apart. So y is dependent variable and x is independent variable. Many students have doubt to how to remember of what is independent variable and dependent variable. Let us take an example. You think you are constructing a pillar. To construct a pillar, you need the base, right? The base should be strong. So base is independent of the pillar which is being raised above. So you can remember in such a way that the base is always independent and the pillar is always dependent on the base. So y is a dependent variable and x is independent variable. So coming back to the definition itself, we can say that if you are having an equation with one independent variable, it is a ordinary differential equation. The examples are given in the slide, like dy by dx whole cube minus dy by dx whole square plus 7y is equal to cos x. And there is another differential equation, d square y by dx square plus 5x into dy by dx whole square minus 6y is equal to tan y. Not only these, you can write many more differential equations. Now discussing about order and degree of differential equation. So why do we need order and degree of a differential equation? So let me tell you, for the corresponding units which we have, we are going to even discuss higher order differential equations. So for that reason, we should have the idea of what is an order, what is a degree. So basically from our schooling knowledge, we know degree is just the highest term or highest coefficient we are giving. So degree doesn't have basically a meaning. If I write some 2x square plus 3 is equal to 0, if I ask you what is the degree of the equation, you say it is 2. But how are you able to say it is 2? Only on the basis you are taking the coefficient and you're just grabbing its highest term in the power. That is called a degree, what we have learnt in our basic school mathematics, right? Similarly, here degree is something from where you are able to take the highest coefficient of the given term. Okay, and coming to order, let me tell you, if I have dy by dx, this is a derivative term. Okay, if I'm writing d square y by dx equal to 0, then here the degree of the given equation and the order are you need to find. You need to find degree and order of the given differential equation. So what is the degree? How do you calculate degree? Just by the basic terminology just now, as we said, you are able to see here degree is 2. So write degree 2. And what is the order? The order is 1. So basically defining more profoundly and more briefly, what we can say, the degree of the highest term without radicals, which is free of radicals, fractions, such degree, such highest term you are saying degree. Okay, here for assume that here the degree is 3, which is the highest among the given derivatives of the term. That is dy by dx whole cube is there, dy by dx whole square is there, and 7y is there. If you see 3 is greater than 2, so 3 is the highest degree. And now what is the order? Order is the highest degree of the highest order. Okay, more profoundly what I can say is that the degree of the highest term is considered as the order. So the degree is 3. Now this term is of order 1. So that is why here degree is 3 and order is 1. Coming to the second equation, if you can see, here the degree is 2 or 1. No, the degree is 2 and the order is 1. No, it is wrong, because I have to take the highest order degree. So d square pi by dx square is of the highest order, right? So this will be my degree. So my degree is of 1 order and order is 2. I think I have mistaken. If you can correct me, let us see. Once again see through the second example and see whether I have tell the degree correct. I said degree 2, but it is wrong. But there is degree is written 1. So can anyone try to correct me there? Okay, let us see through the equation once again. There is the term d square y by dx square. Okay, order of the term is 2, but its degree is 1. You see how? Its degree is 1. So order is the highest order term you are taking, and degree is for that highest order term you have to take the degree. So now we have completed order and degree of a differential equation. Now later we are having exact differential equation. So before discussing why do we need exact differential equation, we first need to understand the concept of degree and order of a differential equation. These play a very mandatory role in understanding what a differential equation is and as well as its application, because depending upon the order and degree of differential equations, you are segregating them. Like today's unit name is first order and first degree, which means that this unit is abided and complicated to the only rules of first order and first degree equation, which means you can never see a second order equation in this whole unit, apart if I go to another unit. So there is a significance of order and degree in understanding the importance of differential equations. To well recap again what we have learned previously, if you are having derivatives in the equation, Such an equation is called a differential equation. And if you need to find the ordinary differential equations, order or degree, or any differential equation for that, not only ordinary, first you have to take the highest term. Taking the highest derivative of the term, whatever the term is having the highest order of the derivative is called the order. Let me tell you here, order is repeating twice. So you have to remember that order in sense the highest order of the given term. If there is dy by dx whole cube, and if inside it is d square y by dx square, then again you have to take this term only. This term stands wrong because this degree is more than the dy by dx. So the term or the coefficient which is having highest degree, you have to take that will be the order, and for the order you have to again take the degree which will be the degree of the given differential equation. Now why do we want to discuss exact differential equation? Differential equation starts from the basic of ordinary differential equation, then partial differential equation, then we learn exact differential equation. So as you have seen in this slide, there is an equation m of xy dx plus n of xy dy equal to 0 be a first order, first degree differential equation where m and n are real values for some x and y. So such equation is called a exact differential equation. The equation of the form, this can be also written as m dx plus n dy as well. Here m can be written as m of xy. Here we are trying to show that the equation can be written in two variables, that is it can be in terms of x and y. Okay. So an equation of the form m of xy into dx plus n of xy into dy equal to 0 be a first order, first degree differential equation where m and n are real valued functions for some x and y. So such an equation is said to be an exact differential equation based on the condition dou m by dou y is equal to dou n by dou x. So this is a necessary and sufficient condition for a differential equation to be exact. That is, to be a differential equation exact or to satisfy exactness of a differential equation, it is mandatory that it satisfies the condition dou m by dou y is equal to dou n by dou x. Now, how do you understand dou m by dou y and dou n by dou x? I don't think we have seen these terms previously. So now, what I have discussed in the past conversation, that is, I said that there are two types of differential equations. One is ordinary differential equations and one is partial differential equations. So in partial differential equations, you have an equation of more than one independent variable. Okay, for partial differential equations, assume I am writing a equation dou square z by dou x square plus dou square z by dou y square equal to 0. So this is a partial differential equation. So why am I saying this equation is a partial differential equation? Because here I am having two independent variables, not one independent variable. So when the equation is having more than one independent variable, it will become a partial differential equation. So an equation having more than one independent variable apparently is called partial differential equation. Okay, so partial differential equation deals with more than one dependent variable and the other properties are same. It will also have derivatives, etc. Right? So coming back now, why did I take the topic of partial differentiation? So the speciality of partial differentiation is only the term with which you are respecting that variable is only given respect. The other variable is given zero respect. In brief, what I want to say is that you assume I am taking dou m by dou y. So dou m by dou y means what? Differentiating partially m with respect to variable y. Now, if I am having, for example, my m is, you think, 2xy. Now, if I need to differentiate it, as per general differentiation, if I do d by, we know the general differentiation, dy of, okay, here it is m, right? Let me correct it. So if I want to just differentiate it, with respect to y. Okay, let us take y. D by y of 2xy. So what will be my answer? 2x? Yes, 2x. Okay, fine. Let me take one more simple example. So differentiating with respect to 2xy, I think I'll get 0 because the x is there, no? But in partial differentiation, that is the speciality. What we do is that we just take only the variable which is required. When I do partial differentiation, you assume when I'm taking 2xy, when I want to differentiate it with respect to y, you assume I'm taking dy of this. Okay, where my y is, I'm sorry, just a minute. Okay, so when I am taking this, when I differentiate, since here x is the differentiation of x is what? 0. Or you take 2x, differentiation of 2x, 0. In partial differentiation, what we do, you assume here I am having 2xy. Then in partial differentiation, here you are taking the x constant because you only have meaning with y. You don't require to take x. So that is the specialty of partial differentiation. What we do is that we only take that term which is differentiating for the particular term or the given variable. Here dou m by dou y means what? You have to differentiate m with respect to y partially, leaving other variables constant. And in dou n by dou x also the same. That is, you take only differentiation with respect to x, and other variables the differentiation should be definitely constant or 0. Okay, and its solution can be obtained by, and this seems like a big term, but don't get confused, it is very easy. If you just see a little bit interestingly into the slide, the equation which is written here is written here again. Only thing is that we have just kept the integration. So it is very easy to remember the solution of the given differential equation, right? So integral of m dx plus integral of n dy. Now there is some content written here. I think we don't know about this, right? So let's discuss. In integration of m dx, what I'm saying here, y is constant. We should take y as constant. That is, whatever term you are having in m, or whatever terms the m consists of, in that y should be constant. And whatever terms in n are there, they should be independent of x. For example, I am having 2xy, 2y, 2x. Now I cannot take this term because this is not independent of x. I cannot take this term because this is not independent of x. I can take this term because it is independent of x. So do you understand what I want to convey? You only can take the terms which are independent of x. You cannot take the terms which are having x in it. And you have to perform integration. As we all know from our previous classes, we know how to perform integration. And here this is a constant. So for the differential equation m dx plus n dy equal to 0, the solution is given by integral of m dx plus integral of n dy equal to constant, where terms of m you should take y as constant, and in terms of n you should take only those terms which are independent of x. So proceeding further, we have a equation. Now this seems a very hard equation, but no, it is not hard. We will try to make it a bit easy. So what we can do here is just perform cross multiplication. So what do you do? Dy into sin x plus x cos y plus x plus dx into y cos x plus sin y plus y. Okay, let me tell you, if I multiply like this, cross multiplication, ma'am, you can say, ma'am, we are having the denominator dx into sin x plus x cos y plus x. It will definitely be 0, no? Because here you are having 0 anyways. So I'm directly taking this equation. Okay, I'm just repeating this step once again. You are multiplying dy with this term, you are multiplying dx with this term, and the denominator is being multiplied to 0. So you are getting the equation. Now if you can see the equation, is it of the form m dy plus n dx equal to 0? Yes, it is of the form m dy plus n dx equal to 0. Isn't it? I think we got m dy, right? Okay. So it is not of the form m dy. Actually, the equation should be of form m dx plus n dy equal to 0, which means the equation is reverse. So here, if you are multiplying dy, you should write this term first and this term second in order to get the equation of the form m dx plus n dy. I hope you are able to get my point. The given equation is of this form, right? This is not the form we have to take, because our equation is of which form? Our equation is of m dx plus n dy form, but we have written m dy. So we just interchange the variables. So the first term what you are getting should be written second. So I am rewriting the equation once again. That is, you write this term first. So y cos x plus sin y plus y into dx plus sin x plus x cos y plus x into dy equal to 0. Yes, now my equation is of the form m dx plus n dy equal to 0, right? So now this is a differential equation. Now what we have to do? We have to show that it is exact differential equation. Actually here it is written solve, but why they have written solve is that if it is once an exact differential equation, we have the solution that is given by integral of m dx plus integral of n dy equal to c, where y is constant in m and in n we only take terms which are independent of x, right? So now we have to satisfy the condition dou m by dou y is equal to dou n by dou x. Only then we can say that the differential equation is exact, and then you can find the solution. See, in the previous slide, if you have seen, first you have to show it is exact, then only you can find the solution. Without exactness, you cannot try to find the solution, because if the solution is not exact, from where do you get the solution? For differential equation to have a solution, it is mandatory that it should have exact differential equation, or it should satisfy the condition for exactness, and the exactness condition is in front of you. So let us verify that. So how we will verify? We have to show that dou m by dou y is equal to dou n by dou x. Now dou m by dou y, how will we do dou m by dou y? This equation is of the form m dx plus n dy. So I am getting m what value from here? Y cos x plus sin y plus y. And what is my n here? Sin x plus x cos y plus x. So these are my m and n. Here m and n are not variables, they are real valued functions. Okay. So dou m by dou y is my first operation I should perform, right? So seeing, let me do dou m by dou y. Let me repeat it once again. Here the normal differentiation is not valid. Here we should do partial differentiation. Partial differentiation, in which means what? You should take the differentiation only with respect to this variable. Other variables are 0 for you. This is the only hero variable. Here my hero variable is y. So I should only take terms with respect to y, and other variables will definitely become constant without hesitation. Okay, let me try it. Okay. See, dou m by dou y. So here I am having y cos x. What did I say? The other term will become constant. So this is what, this cos x is a constant. Throw it out, write cos x here. Now differentiation of y is 1. This is our normal differentiation, what we do, y. So differentiation of y is what? 1. Next, differentiation of sin y is what? Cos y. Next, differentiation of y is again 1. This all differentiation is with respect to y. That is why I don't have any hesitation here. But here I have, because this is a x term. No, we have allergy with that. So that is why we just put it out, or we take it as constant anyway. Okay. Previously in my lectures, I just have told that constant or 0. Okay. It's not constant or 0. It's constant. In flow, I just said it's 0. It's constant. Constant essence, you should put it out. Okay. Now let me take, so my dou m by dou value is cos x multiplied by 1 is anyways cos x, right? So cos x plus cos y plus 1. And my dou n by dou x value is what? Dou n by dou x. Now again change, flux change or switch change, because the differentiation here is with respect to x, not differentiation, it is partial differentiation, which means other variables again we give zero respect. So here I am having sin x, you can happily differentiate. So differentiation of sin x is cos x. Again here I am having y, so I should throw it out, it is constant, so write it as like it. Next, x differentiation is 1 only, no? 1 plus here differentiation of x is 1. So if you see, my dou m by dou y and dou n by dou x are equal. So ridiculous. Doing something, I'm getting two equal functions or two equal values, na? So do you see these two values are equal? Or the two answers are equal, that is dou m by dou y and dou n by dou x are equal. So what did I get? Dou m by dou y is equal to dou n by dou x is equal to cos x plus cos y plus 1. Let it write. So therefore dou m by dou y is equal to dou n by dou x. That is very good and happy that we have proved the exactness condition. Now you can say perfectly that this differential equation is exact because it is satisfying the condition for exactness. Now once we have checked the exactness of the condition, now what is remaining is just to find the solution. As I have written the solution here, integral of m dx plus integral of n dy is equal to c. See, this is the solution. Okay. Now you have already your m, right? Where is your m? This is your m. So what I have to do? I have to treat here y constant. Okay. And I have to perform my integration. Now when I perform integration, putting y constant, we throw y out. Integration of cos x plus sin y. Again y is constant, so you have to not integrate. At the same time you cannot even throw out, so we write it like that only, plus sin y plus y. Just write it like this. The integration only is for this. Okay. Next, after integration, what you have next? Integral, after again integral is there, plus again integral n dy. Here one thing you have to remember is that only terms of n which are independent of x. I have not written here because there is no space here, but here if you can see the step 3 here, n terms should be independent of x. Only those terms of n which are independent of x. So if you see the n here, sin x is there, this term is having x. If you see next term x cos y, this fellow is also having x. If I see the next term, this is also having x. So basically I have allergy with x for n, while taking n, that is when you are taking dou n by, not dou n, I'm sorry, while taking integration for n. When you are taking the solution for n term, it is very mandatory that you should have allergy with terms which are consisting of x. So basically every term is having x, that is why I cannot take this. So there is no term to integrate for n. So basically this will become 0. Okay. So now what is integration of cos x? That is sin x. And this is as usual you will write it, is equal to c, because here c is there in the formula itself, right here. That's it. And this is the solution of the given differential equation. This is what we were driving from the unit, from starting of the unit, right? So this is a solution of the given differential equation. See, seeing the differential equation, it seems that it is little bit tough, it is logical, but there is no logic. Only thing is that you have to perform cross multiplication, check for the exactness of the condition, and then once it's checked, you can proceed with finding the solution of the given differential equation. Okay, let us have a look at another problem. If you see here, second problem, solve x e power xy plus 2y into dy by dx plus y into e power xy. Always remember, when you are having a fractional form like this, one thing you can do is that just blindly perform cross multiplication. That is what I do here. You see, x e power xy plus 2y into dy plus dx into y into e power xy equal to 0. Okay, so this equation is of the form m dy. Again I'm getting m dy. So this is not m dy. Always remember the equation is of which form? M dx plus n dy. It is not m dy. So it is in reverse. What you have to do? You have to write this term first. So y into e power xy dx plus x into e power xy plus 2y into dy equal to 0. Yeah, now it is of the equation m dx plus n dy. Now what is my m value here? Y into e power xy, and my n value is what ma? X e power xy plus 2y. Right? Next step, what we have to do? We have to verify the exactness condition. This terminology is known as exactness condition. Okay. So dou m by dou y. So partial differentiation with respect to y. Always remember it is partial differentiation. It is not normal differentiation, because there is a difference between normal differentiation and partial differentiation. Why I am recapping this so many times is that in normal differentiation we just perform differentiation irrespective of taking variables constant. But in partial differentiation it is very much mandatory that you have to perform the differentiation only for the given variable, and other variables will have no significance in the differentiation. Okay, so while performing dou m by dou y, always remember x is constant. So y, this is in the form of uv. Okay, you have to even have that sense of derivatives as we usually do for following a differentiation unit while we are differentiating functions. So here we are having u into v. If you can see, this is there are two terms, no? uv. So what is the formula of uv? For differentiation of uv, what formula we do? We use uv dash plus vu dash. So y into e power xy. Now what is the xy differentiation with respect to y? X will be constant and y differentiation is 1. This is chain rule. I hope you people remember. If you just have a look on 2x cube, what we basically do, we first multiply this 6x square. Do you remember this? Or I'll take more simple example. You take 6 cos 2x. Okay, now if you want differentiation of this, what we do? Cos x differentiation is minus sin 2x. Again, differentiation of my 2x is 2. So you are having totally minus 12 sin 2x. I hope you remember this chain rule. Similarly, we follow here also. So we are done with uv dash. Now we have to do vu dash. So vu dash is e power xy into differentiation of y is 1. So that is dou m by dou y is equal to y into e power xy x into y plus e power xy. I think we can take common e power xy, right? So you can write like this. Next, dou n by dou x. Dou n by dou x. How now? Again the variable change. Here my differentiation is with respect to x. So taking n, differentiate it with respect to x. Again here I am having two terms. So I have to perform again uv. So x into e power xy. Remember here my differentiation is with respect to x. So y will be constant. So I'll write y here into 1 plus e power xy into just a minute, x into e power xy, y into 1 plus e power xy into x differentiation is again 1, and this term is 0 because we are performing partial differentiation with respect to x. So y term will be 0 plus 0. I think you are getting equal, right? Is it? Yes, we are getting again equal, taking common. So what we are getting? 1 plus xy. Yes, we are getting equal. So yes, we are again happy. We got same. So that is this verification process is crossed. It has successfully crossed the obstacle, that is dou m by dou y is equal to dou n by dou x. Now what we have to do, we have to find out the solution. So finding out the solution, what we have, integral of m dx, again we have to take y constant. Where is my m here? This one. I have to take y constant, so I'll throw y out. I have written y here, right? I have written y. Then what I have to do, I have to integrate e power xy, right? Next, plus terms which are independent of x. This is having x. I cannot take this term. This term I can take, plus integral equal to c. So e power integral xy, we have the formula e power xy by xy, right? Plus 2 into y square by 2 is equal to c. xy plus y square is equal to c. E power x into e power y. And one more thing I forgot here. See, this is integration with respect to dx, right? So what we do, we only have to take the necessary term. We cannot take extra people into the consideration. So I can split this e power y. See, it is in terms of e power x into y, which can be written as e power x plus y, right? It can be written like this. So what I can do here, so y into this one I'm writing here, y into e power y I'm taking out ma. Right? So I'm ending up with the solution y into e power xy by xy plus 2 into y square by 2 is equal to c. So there we have ended up with the solution of the given differential equation. Going to the next unit, next slide, I'm sorry, we have another sum. So for this sum, also the same process. You have to take m dx plus n dy equal to 0. You should have the equation. I hope the equation is in that terminology. You can directly take the exactness condition and verify whether it is satisfying or not, and then you have to find the solution. Okay. So later, I think you people will be able to do this problem, right? Then there is one more problem, and then we have the point of integrating factor. So these two problems, we will do it in the next module. Before leaving, I would want to introduce the concept of integrating factor. So long we have discussed about what a differential equation is, what are the type of differential equations, and then how do we use a differential equation, and then the difference between ordinary differential equation and partial differential equation. And then we also have seen what is exact differential equation, what condition it should accept or verify in order to get an exact differential equation, and we have even solved two problems on basis of exact differential equation. Now you just assume that there is a differential equation which is not exact. Okay, you're having an exact differential equation which is not exact. Then what will you able to do with that equation, right? What can you do with that equation? You have to make it exact on anyways. So what we do, we just need a magic. So that magic name is integrating factor. So just multiplying the given differential equation with a magic, that equation turns into a exact differential equation. That magic we are naming here as integrating factor. So in other words, you can say a equation which is physically handicapped, you are giving it all legs and hands to move and dance by just multiplying with the integrating factor, and that magic is given by the name of integrating factor. So just multiplying the given differential equation with the required integrating factor, it is becoming an exact differential equation. And there are many integrating factors, as you can see here. Depending upon the variant, we just try to multiply the integrating factor with the equation, and we turn it into a exact differential equation. So we will continue again in next class. Thank you.